A stellar nebula is a vast cloud of gas and dust in space where new stars are born. These nebulae are often referred to as stellar nurseries because they provide the raw materials and conditions necessary for star formation. Here's a more detailed explanation. Composition. Stellar nebulae are primarily composed of hydrogen and helium gas, along with dust particles. Formation. They form when regions of the interstellar medium, the gas and dust between stars, become dense enough to collapse under their own gravity. Star formation. As the nebula collapses, the material at the center heats up, eventually igniting nuclear fusion and forming new stars. Different types. While all nebulae are vast clouds of gas and dust, they can be further categorized into different types based on their appearance and how they interact with light. Emission nebulae, for example, are nebulae that emit their own light, often due to nearby hot stars. Reflection nebulae scatter the light of nearby stars. And then there are planetary nebulae and supernova remnants, which are associated with the end-of-life stages of stars. Examples. The Orion Nebula is a well-known example of a stellar nebula, notable for its bright, star-forming regions, according to the NASA Science article. A nebula becomes a star through a process of gravitational collapse. Gravity pulls together gas and dust within a nebula, causing it to become denser and hotter. This dense core eventually reaches a critical temperature and pressure where nuclear fusion begins, transforming the core into a star. Here's a more detailed explanation. 1. Nebulae as stellar nurseries. Nebulae are vast clouds of gas and dust, often considered stellar nurseries, where stars are born. 2. Gravitational collapse. Within a nebula, gravity causes denser regions to begin collapsing in on themselves. 3. Protostar formation. As the material collapses, it heats up, forming a protostar, a very young star still gathering mass. 4. Nuclear fusion. If the protostar's core gets hot and dense enough, nuclear fusion begins, where hydrogen atoms fuse to form helium, releasing tremendous energy. 5. Star formation. This fusion process stabilizes the protostar, and it becomes a true star, shining due to the energy released by nuclear reactions.